are very straightforward questions here, and then they give you some sequence. It's obviously every time we just add extra 4, so this is AS. And then this one, B itself may not be any metric or geometric sequence. We are not sure, so we handle it later. Just talking about AN first. AN from A1 to AN, so they are asking about the sum of first n term. Of a AS, a metric sequence. So obviously we are going to use the formula Sn is equal to 2a plus n minus 1 time of d times n divided by 2. Or you may consider it is the first term plus the last term times n divided by 2. To know what is a, what is d, for some of you may be explicit. A is -1, d is 4. But if you are not realize that, then you may try to calculate here a1, a2, a3. Once you write down the first 3 terms, I'm sure that you can get the a and d. 4 times 1 minus 5, then you get the first term is -1. Our starting point is -1. The second term, 4 times 2 minus 5. So that means compared with the previous one, we have extra 4. So that is 3. 4 times 3 minus 5, we get 7. So every time the changes is plus 4 here. Of course, it's the same reason as slope-intercept form. So anyway, we know that A is equal to -1. We know D is equal to 4. Then we just plug it in, 2 times -1, and then plus n minus 1 time of d, d is 4, times n over 2. And then we just tidy up this expression. Every item divisible by 2, so 4 divided by 2, 2n, minus 6 divided by 2 is 3. Times of n. That's how you express in terms of n, or you may expand it to n squared minus 3n, which are the same. Part B is also not difficult, but maybe you think that it's too complicated, then you just focus on your target and try to express it in terms of n first. Then maybe you get some idea. So we have left hand side, we have log b first term times b second term times b third term until b n term. If you remember the log property, we have log a product is equal to log its factor plus another log factor. So what inside is something multiplied inside together. Then we should use the property try to separate them. Therefore we have log first term, log second factor, log third factor until log the n factor. Now, I think it's a suitable time for us to use the definition of Bn. So we try to substitute inside. This is log power of 10 and then 4 times 1 minus 5. Hey, hold on, it's log quite familiarized. It seems that we just calculate just now. So in part A, we know this is -1. Now this is 10 power 4 times 2 minus 5. That means log 10 power of 3. It seems like it's the second term just now. Now we know that an and bn are related in this way. So log b3 is 10 power of 4 times 3 minus 5. That means log 10 power of 7. Finally, this one is log 10 power of 4n minus 5. Don't forget the dots inside. Both the base of the number and also the base of the log are the same. So that means this is just -1. This is the A series, A sequence, first term, second term until the n term. So basically this is the same as A1 plus A2 plus A3 plus AN. Therefore, we just simply use the result 2n squared minus 3n in part A. We finish the most complicated part and then we get it back to the original requirement to handle this inequality. Therefore, we are going to solve the condition is 2n squared minus 3n and then smaller or equal to 8,000. This is an inequality with power of 2. So this is quadratic inequality. The strategy to solve it is to put everything to one side. Compare with 0. After that, because this coefficient is positive, I know that the graph is opening upward. And then we can get two roots, which is n1 and n2. We are talking about the height which is below the ground, smaller than 0. So we are talking about this section of our line. That means our solution, we can choose any n is between n1 and n2. That's how we solve quadratic inequalities. If we are asking for larger than 0, then we choose 2n. But now we are talking about the middle region. So it's directly jump to the conclusion. Our answer, that means the feasible choice for n is within two values, n1 and n2. That means by formula 1 we get 64, and then we get another smaller value, negative 62.5. They are asking for the greatest value such that fulfill this requirement, and we accept the equal case, so the greatest value is 64. To fulfill this requirement,